Okay, so this presentation also is in Brazil. We've got all the Brazilian ones near the end here. So this presentation is about predictive modeling of shell mounds in the coastal region of Brazil. Let's see. So the objectives of this study were to the identification of geographical characteristics that were common to shell mounds, which in Brazil are known as sambaquis, and the prediction of probable locations of other shell mounds, ones that have not yet been documented. This involved two main parts to the study. One was a statistical analysis. This involved looking at known shell mounds, seeing what data we already knew about them, trying to empirically categorize the data, getting the opinions of other researchers who had worked with them, some in Brazil, some abroad, to try and create like an expert system, and looking for whatever data was available on the sites. There's a lot of information from the past publications. It's not always all the same for all the material, for all the sites, but we try to fit it into categories that can be measured. In the modeling, then we take a look at what types of data we have, and not only what types of data there are, but how weighted are they? How much value or how much importance does each category of data have? Some are more important than others. We had to determine that through the statistical analysis. So including some of the data that was modeled in the early stages was the topography. Part of that was done through digitizing topographic maps and finding the outlines of the topography, creating digital elevation models from them. Mapping the known rivers. There's some slight variations in as you get near the ends of the rivers. Sometimes they'll move a bit, so this isn't accurate to the meter. But the larger rivers should stay the same, and we generally look at depressions. On this map here, the orange plus symbols, these are the highest points within the region, so they were plotted as well. Some of the ones that are the pink plus symbols, these are in rocky outcrops, so they're also high points, but they're not like the rest of it. Most of this area, other than this area where you see a lot of the topographic lines in the western area, this is rocky outcrops. The rest of this area is largely a sand area. And these rocks here, you can see there's a black line running along it. That's actually a modern road. And it runs along the edge of this rock formation. The rock formation marks where is the most inland the sea was in the past, because the sea levels have risen and fallen several times over the past few thousand years. So the most inland that the coast was at the edge of this rock formation. And that was part of the reason this area was chosen for a test area, is that this is the farthest you could actually possibly find the shell mounds. You couldn't find there any more interior, because then you start getting into mountainous like foothills, and then into actual mountains which go 900 meters above sea level. The average sea level in this area, the study area varies between about 9 to 12 meters above sea level. So it's a relatively flat land, but it's also a mangrove area, which is a salty swamp, which makes passing quite difficult. So here we're looking at the black area marked in there is the rocky outcrops. And the rest of it was after the scanned maps were taken away. The green areas indicate permanently wetlands. They're not lakes, but they're a more swampy area. They're permanently saturated. So what they likely indicate is that there's a basin under them which is retaining the water. This is an aspect model where after looking at the digital elevation model, it was marked into squares, and it was determined which faced a certain degree north, a certain degree northeast, a certain north by northeast. And what we highlighted here, what we found out from the statistical studies of the known sites, was that there was a very slight tendency for sites to be facing slightly east or a bit northeast. So these sites here are indicating, giving a value to what's facing east or northeast, and a little bit to the bit west, south, northwest by west, and a little bit to the north. So they get a slightly lower value, but so this is indicating areas that are a little bit higher value. So the way after this, we had a lot of data after I had digitized stuff and got it all into one system. We had to give values to different things. So I found through the statistical analysis that some things have higher value. They have a more common occurrence with the known shell mounds. So some things occurred slightly common, were a bit common. Other things were very common. A lot of them were very commonly within a certain distance of rivers. Very often they were not in the very lower areas. Yeah, as I said, there was a slight tendency for them to be east or northeast. So then, based on giving everything a value, like you give it a value, then I had to create a new a raster map, which is a grayscale map where each level of gray, there's between white to black, there's 255 different levels of gray, and each one has a different value. And I modeled it two different ways: distance from the high value areas, or the highest value, the highest weighted things, and also there's an add-in called the model builder, where you can take many of these things all at the same time. So in one way, you're looking at them all together, giving each pixel a value, and the other, you're looking at each characteristic individually and then putting them one on top of the other and adding them all up. So you get similar results, but I'll show you how they're actually a little bit different. Here's an example of the distance from model, where you take one thing only. In the other side, where we've got a model builder, we've got many different characteristics. For example, distance from rivers. If it was between 0 and 40, it had a very low value. Like, we didn't give it a value. If it was between 40 and 470, it got a value of 1. But if it was within this range of 150 to 470, it actually got a value of 2. So it was a slightly better area. So this is probably because the rivers they fluctuated in size, or the rivers may have just been larger at the time. So people obviously weren't living in the rivers, or they weren't building their sites on the rivers. If it was near a wetland, a permanent wetland, it actually got a negative value, slightly east. So this was a simplified version of the model, because if I put them all on here, I couldn't fit them on the screen. So anyways, we give it a weighted sum one as well. And so if I give it the weighted sum, we get this. If you get all the factors together and then just stack them one on top of the other, giving extra values, then what is the most valuable area, and then distance from it, you get a map like this. So these areas with the really dark green are the areas which should have a high probability of being new shell mounds. Though if I use the model builder and everything is analyzed separately, and then the first one they were analyzed separately. In this one, where they're all analyzed at the same time, we get a much more complex model. So this one here is more simplified one. And then we get this one here, where the green areas, particularly the darker the green, are the areas where there should be a higher probability. The areas that are red should have a very low probability of there being shell mounds. So what we'll see is that there's actually there's a bit of correlate. There's some similarities between the two. So after that, I just marked them out. It was very simply made polygons over the areas that had the highest probability. This was so that I could import it into a GPS. It's a lot easier to walk out into the field with a polygon map instead of a large raster map. And just to show you where those sites actually were, this is the original topographic map again. Here are my areas of interest. That red line that runs sort of near the bottom a bit diagonally, that's a highway. So it's a very easy area to get to. So I would go down to where that black line and the white line meets. There's a town there, and I would start my surveys from there. The picture of the GPS and a Google Earth image to show you, kind of what the area looked like. You can see some of the areas that are deforested. There's one in the center top part. Someone's created a bit of a farm in the middle of the field of the mangrove there. It's quite labor intensive to do it. You have to drain the land, but people are doing it. Anyways, so there's my area of interest. So I start doing the field walks. Here's some views of what the area looks like. Sometimes it's a really nice scenic area, but sometimes you get really dense vegetation. Sometimes there's openings with the trees, you can walk through them. You definitely need a machete. A chainsaw would probably be a blessing to go through here. But you're also some areas where there's small creeks. Some of them you can step over. Some of them got sand at the bottom. Some of them are silty. Unfortunately, you'll also come into areas where it's like a mud. And it starts off like soft ground. And you might end up walking up to your knees. And you have to go back and go around. You're constantly having to cut the vines and stuff to get through the area. But getting to some of the high interest areas, some of them did have shell mounds. So these were not ones that were already known. We can't actually say that, like I can't say 100% they're archaeological sites, because in order to do that, you have to excavate. And I don't have an excavation permit, just I'm able just to do field walking. So what I do is I go along, just brush the organic material off the surface, see if there were shells, and just keep doing it to see what was the extent of the shell areas. Some of them ranged from being 10 or 15 meters wide to, I think the largest might have been like 25, possibly 30. It's hard to tell because sometimes it's difficult to go through the ground. Sometimes there's like a strong like overgrowth on the ground that's really difficult to push away or to climb over and stuff. Anyways, so you got quite a variety. Yeah, there's some more pictures for examples. So here we go back to the topographic map again. So those areas to the very north, I wasn't able to get to them. I might get to them in the coming year. I'm also planning on going to some other areas to redo the same study to see how it stands up. But anyways, on this map here, those yellow dots indicate where shells were found on the ground. Shells in high concentration. It wasn't just one or two shells independently. They were sets of them distributed around the ground. So you can see some of them do correlate quite well to this areas. Some of them I wasn't able to get to the areas. For example, in the south of the red road, you can see there's an area marked, and they have shells near it. I couldn't get into the area where the actual shell, where the prediction was, because it's a rice field now, and there's a thin path about 1.5 meters wide going through the middle of the rice field. If you step off of it, you'll go up to almost the top of your legs in mud. So there was no way to walk through it, but I could see from even the edge of it that there was a high concentration of shells. So I would predict if I could crawl across the mud field, there would probably be something out there as well. Or if I came back another time when the farmer was plowing it, I may actually have better success. Yes. So some of the difficulties of this study were a lack of detailed geographic data. So there's the maps for the area vary. The soil maps, I think I got soil maps at 1 to 50,000 scale. I got topographic maps at 1 to 25,000. The hydrographic maps, I think I got some of them at 1 to 25,000, some at 1 to 50,000. The bedrock wasn't such an issue because it was mainly a limiting factor. Sometimes there was missing or inaccurate information about some of the archaeological sites. So when I did the statistical studies, some of the sites were missing data. So you couldn't do a statistical analysis based on all of the sites. You had to sort of say, okay, out of 250 sites, well, we're only doing 175 have what type of shell were in it, or another have what distance was it from the water, or other stuff like this. The field work was also a bit difficult because of the dense vegetation and the deep mud that made the fields and the mangrove really difficult to walk through. Like some point you are wading through rivers up to your waist. It's also important you have to go there with someone else because there are a lot of snakes. You'll saw in my cover page there was an alligator, a caiman actually. I actually did see one. There was one of the large rivers. It was on the other bank. I could just see its nose sticking out of the water. So obviously I wasn't going to swim across that river. Yeah, so it's a bit of a difficult area to go through. Yeah, there's also one of the problems is there's a bit of reluctance of landowners to indicate if they've seen sites. Some landowners were quite open and said, yeah, I've seen shells, and they indicated approximately where they were. And in one case, I was actually able to find one of the shell mounds was in an area that I considered, it wasn't the highest probability, it was sort of like a second tier, but when I went out to look at it, I marked on the map, and it actually turned out there was something there. So this was quite good. Yeah, so these are some of the difficulties. Some of the things I'm hoping to do for the future is to check out other areas along the coast. So this area was an area of about 7 kilometers by 5 kilometers. It was the first test site to test how the model fared up, like how much of it the predicted sites, or the high probability sites had stuff. Just as a note, I did check out a lot of the low probability areas to see, if it wasn't just random. And the low probability, none of the low probability areas had signs of shells in them. I'd also like to do more detailed models. This may require collaboration with, or will require collaboration with other specialists working in the area, particularly biologists, shell biologists, and possibly the geographers. One thing I would like to do, and this was an early thing I had tried doing, was working on the interior of the state in the plateau region, which ranges from about 900 meters above sea level in the east to about 450, 500 meters above sea level in the west. It's a basalt plateau. One of the difficulties there is that a lot of the sites that I have data on were done specifically for hydroelectric projects. So there's a bit of a bias. They're all located near rivers. They're all on sloped ground. So the data is a bit biased. And there's also the problem of working with defining the terrain. In the coastal areas, it was relatively flat. So terrain was a bit easier to define. Yeah, so I should say thanks. None of these people I think are online right now, but these were some of the people that came out in the field with me to help do the field work. So yeah, maybe they'll see the video later. Yeah, and I should also say thanks to the university and to the anthropology department and to the copies department for funding this research. Yeah, so that's my presentation. I hope you all liked it. If you have any questions, we can talk about them in the discussion board.